Hello everyone, I'm going to show you how you can quickly deploy a smart contract onto the Ethereum blockchain, and you can see your smart contract up on Etherscan, which is a blockchain explorer. And all the contract is going to do is just will simply show your name. So you can have your name written onto the Ethereum blockchain, which is super cool. And the only tool you need first to get started is this plugin called MetaMask, which runs in your browser, and that's going to be your bridge to the Ethereum blockchain. Once you have that installed, head over to remix.ethereum.org, which is simply an online code editor. It's called an Integrated Developer Environment, or IDE, and that's where we will write our code. I have the code right here. I'll walk you through it, and then we will deploy it. So this is a very simple 17-line smart contract. It's a complete smart contract written in Solidity. The very first line, I would just ignore that for now. Just know that you need that in every smart contract. It's essentially telling the compiler what version of the Solidity you are using, so that it knows how to interpret some of the keywords. So we're using 051 for this one. Your contract starts with the name contract, and then just a label, a variable that you can call it whatever you want, and then everything in your smart contract is contained in these two curly braces, and that's in there. Then our smart contract has two variables, one by the name of name, which is a string, which is going to actually store your name. It just has, it's sort of a string, it's just like a line or a sentence, a little short piece of text. And the other variable is locked, which is of type Boolean, or bool for short, which is just going to be a certain flag that we're going to use so that at any point in time you can lock the ability for anyone to set the name, including yourself. So once you write your name to the smart contract, if you want, you can keep updating your name, but once this flag locked gets reset to true, then at that point, no one else can modify or change the name. So the function to set the name is simply called setName. It has the ability to pass in a parameter that we are calling n. It also of type string. Memory just means it's fleeting. It's only being stored to short-term storage, and it is a public function. That means anyone can call this function, other smart contracts. Anyone who wants to interact with the blockchain can call this setName function. Note that the name variable up here was also public, and that means other smart contracts can interact with it, or other software, front-end software, knows that this is something that is readily available to be displayed. Note that if something is private, it does not mean it is private in the sense that no one can access it or read what's there. It doesn't encrypt it or obfuscate it in any way. It just means through a program or on the blockchain, it cannot be accessed. I mean, programmatically. Now, all right, so now to continue with the setName function on line number 11, that's where we actually store the sent in name, which this gets passed in. We're actually storing it to our variable name, which lives and persists for the lifetime of this whole smart contract. So we just want to take this temporary value and assign it to something that's permanent. I skipped over line 9 because I first want to show you the second function, which is lock, which will just flip the value of the locked flag to true. And that means once this is true, we no longer want anyone to be able to call the setName function. Or rather, we don't want the functionality to happen within this function. So at the very first line, there's a built-in primitive or a built-in operation that's called require, which will enforce that whatever is in here is indeed true before it continues. So if this evaluates the false, this function will eject and won't be able to continue. So this would evaluate to false when locked is set to true. Then the exclamation over there means not true. means this would then be false, and we won't continue. All right, that is a line-by-line overview of this smart contract. We are ready to deploy it. Now, Remix allows you to deploy your smart contract to the Ethereum blockchain. I just want to show you on the right side over here, we have different tabs: compile, run, analysis, etc. On the compile tab, it's very helpful to just have auto compile selected, because like this, if you always make any changes or modify the smart contract, you're automatically deploying or using the latest written version. It's almost like an auto save in that sense. Enable optimization, we'll leave that off for now. The run tab is going to have our main functionality and our main interaction of what we need in terms of deploying this to the blockchain. First thing is, under the environment field, set that to Injected Web3. Make sure Injected Web3 is selected, and that means it's going to talk to MetaMask, that this web page can then talk to MetaMask. And that's it. Now we are ready to deploy. These are buttons over here, deploy, and this one, add address. I'll hit deploy. MetaMask pops up, asking me whether or not to confirm that indeed I want to write this to the blockchain. We will be using the Rinkeby test network. So let me just hit confirm and I will explain that. If you look at your MetaMask, up top you could select the main Ethereum network or a variety of test networks. Everything we go through in this instructional you can do on the main network, but for the sake of the fact that we just are doing this for illustration, we don't want to use real Ether, you can use the Rinkeby test network and you can get Ether. I have some in here, but the way you get some on your own is you hit deposit, scroll down to get Ether. That will bring you to this web page on the left side over here. There's a crypto faucet. Click on that. And you can go through then the steps. There's just a few steps here. It'll take you a couple minutes on how to actually get Ether sent to your MetaMask address. So now if we go back to MetaMask, we will also see that it shows over here confirmed. Once that shows confirmed, it also means that we will have here this little box called deployed contracts. You have to click on the name or address over here to actually expand out the attributes and the functions of our smart contract. If I click on name now, it's just going to show empty. It just says string, but there's nothing there. That's because we haven't set the name yet. But if we set it, I'm just going to type my own name, put it in parentheses. That signifies to Remix that, hey, we're passing in a string. We're putting in some text. I'm going to confirm that. And it just differentiates between sending a string or some number. If it was a number, you would not put text over here. And now that transaction, I believe that, still shows as pending. It takes about 15 seconds because right now it's this transaction, the network has heard about it, but has not yet packaged it into a block. And now it just was confirmed into a block. And at this point, when I hit name, I will indeed get my name. I'm going to leave the lock function open for now. I'm not going to lock it. Anyone could go in and actually override the name that's in there currently. I do want to show you something else that's really interesting, and that is showing this smart contract on a blockchain explorer, as I said at the very beginning. If you go to MetaMask and go to the transaction, which shows your contract deployment, click on that. There's a little arrow on the right side here. You click on that. It brings you to the transaction where this smart contract was deployed. And in fact, within it, it shows to, and it says contract, and it has another address. And you can click on that address, and this is the actual location where the smart contract lives. So you can see over here that there are a number of tabs. Right now, for me, the code tab does show the actual contents. And I realize the reason why this is happening is because I previously had stored the code. I had previously uploaded the code myself. And if we look but I will show you how you can do that yourself. It even says over here, contract source code is verified via similar match, similar match code at contract something. In fact, if you deploy this code exactly the way I have it, it should match for you automatically. But I'll show you just in a moment how we could do it yourself. You know what? Let's go ahead and do that. I'm going to change something in this smart contract. I'm going to say, maybe I'll change the variable. I'll change the name of my smart contract. I'll call it my name stored here. Okay, simple as that. I'm going to copy that. I need to actually deploy this smart contract. I'll confirm. This is obviously just the label. The stuff that's in blue, those are keywords of the Solidity language, right? That's built-in text for the language. The stuff in black is stuff that I write myself. This is some weird gray color because it is built in to some degree. Okay, so that confirmed on the blockchain. I will continue henceforth from that smart contract. Right, so when yours probably looks like this, you just have these 3 tabs. If you click on the code one, we can click verify and publish and paste in the source code. For the name, make sure this name matches exactly the name you gave here for the smart contract. Actually, I want to paste this in. Sometimes doing a regular Control-V throws in some kind of hidden characters where it throws Etherscan off. So I do want to make sure I'm just copying this and paste it without any formatting. On a Mac, by the way, if you hit Shift Option while you do the Control-V or Command-V, it will do a clean paste. I don't remember offhand on Windows what the command is, but if you run into problems, you know that's probably the root cause of it. Now for the compiler, I needed to match this 051. I'm just going to go down to 051 commit, the one that just says commit. Optimization, change that to no because we did not have it optimized. Scroll down, I'm not a robot. Verify and publish. And it's now confirming whether or not this source does match the contract bytecode, and indeed it matches. And if I now click on that to get back to the contract, and now it has all these tabs built in. I have the read contract where there's nothing to read because it's currently empty. It has a write contract as well. I'm going to set my name, going back to Remix. This is the new contract on the bottom deployed. This is the one that I deployed previously. I'm going to, again, write my name over here and do set name, confirm to the Ethereum blockchain. This will take, again, a little bit of time. And if I look at the transactions, if I refresh, this should show one as pending. Huh, it doesn't show pending yet. Well, okay, it just showed confirmed. And indeed, now when I go to read contract, it has my name. This is the one I just deployed. This time, I just cycled back to the one that was deployed previously. So these are 2 separate contracts that have my name. This is the URL to it. So if you were to copy this URL, open this up from any browser anywhere, you will see your name. Now keep in mind, anyone can now override it. So now this write contract tab is here as well. And you can interact with your smart contract directly on Etherscan. You don't need to use Remix. It allows you, again, to set the name or hit this lock function. You do have to connect it to your MetaMask, so once I do that, I will have the option to write or do one of these 2 things. So there you have it. That's how you can now write your name onto the Ethereum blockchain. Of course, you could do this on the mainnet. It's exactly the same, and your name will live there forever, for eternity. There's no way it's going to get erased unless, of course, in some really unfortunate circumstance if the Ethereum blockchain goes down. But currently it is running on something like 12,000 machines around the world, so it's pretty secure up there. Hope to see you again on a future video. Take care.